So let's take a look at the repository which we are going to be using for the Maven project. Once you visit my GitHub, DevOps in my GitHub, you want to visit the Maven Learning repo. We are going to be making use of the Maven Learning repo. Now, this repository has been constructed to give us an end-to-end understanding of Apache Maven in addition to the brief introduction which we did, and equally giving us the possibility to build the necessary, or giving us the possibility to understand the necessary Maven build lifecycle. Once you visit this my repository, the first thing which you want to understand is I maintain this repository, and from time to time I make sure that the repository has most up-to-date information. So you want to always check the repository for new changes or for new fixes. And if you come across the repository and you're interested in making use of this repository in your projects and in your project code base, you want to fork this repository among the list of repositories which you have. And of course, if you're interested, you can also give me a star to give me a thumbs up in the work which I'm doing with this repository. Now, this repository, basically I've been able to add some more technical information which you need to understand this repository. First is what Apache Maven is. We've already had that conversation in a previous module. We also have a simplified background why Maven started, why the Apache Software Foundation began running Maven. And then we equally have the Maven architecture, which is more detailed on how we can deploy Maven projects, having our local repository, our Maven build system, and of course our remote repository. Now we equally have our sample pom.xml file. This is a complete pom.xml file which you can definitely use to customize in setting up your own Maven project. What is worth noting here is the project details. Now we can, with the help of comments, we can see more information. You see here we set Java and Spring Boot versions. We have dependencies for Spring Boot and testing. We have plugins for Spring Boot, Java compilation, and SonarQube analysis. Remember, I mentioned that in the pom.xml file, we can use that to effectively specify the plugins and dependencies which we are going to be using in the project. And then even with this given pom.xml file, we can specify the Nexus repository which we use for deploying our artifacts. Here you have to specify the IP address of the Nexus repository. And remember, Nexus works on port 8081, so you must specify the port on which Nexus works. And then also we can set up profiles for SonarQube. We have profiles for SonarQube and Nexus credentials, where you specify equally credentials which will be used to access the Nexus server as well as the SonarQube server. So yes, just a basic summary of the various components of the pom.xml file. We have the project information, we have the dependencies, we have some build plugins that enable us to build a Java project. We have Spring Boot plugin, Maven compiler plugin, and SonarQube plugin. And then we equally have the distribution management, which configures Nexus endpoints for deploying releases and snapshots, and of course profiles for SonarQube and profiles for Nexus. Again, I iterate in this repository why we need to make use of Maven dependency management, build lifecycle management, build consistency, and wide ecosystem support, where we can integrate with other IDEs. Now, again, I reiterate the various phases in the Maven lifecycle. We have the default lifecycle, which we have Maven validate, compile, test, package, verify, install, and deploy. We equally have the clean lifecycle, which enables us to handle project cleaning, removing all files generated by your previous build to avoid having your build server being crowded with unnecessary files or unnecessary data. And then the last lifecycle which you have is a site lifecycle, which basically manages the creation of the project documentation. Remember, we mentioned that with the help of Maven, you can actually document your project. And again, we iterate some common Maven use cases: Java build environment and management, dependency management, continuous integration, CI integration like with Jenkins, with GitLab and GitHub Actions. And we equally have code analysis, static code analysis with tools like SonarQube, Checkstyle, and of course the ability to package and release management for your jar and WAR files. So if you were to integrate Maven with a Jenkins pipeline, this is what a simple Jenkins pipeline for Maven stages will be: Maven clean to clean previous files that were in your previous build, Maven test, and then Maven deploy. This is a sample Jenkins file for Maven, and then this is a sample execution command for static code analysis, or to run a static code analysis on your Maven server. And then of course this is the pom.xml configuration to push an artifact from Maven to Nexus using the Nexus URL. And then we also have a Docker file that helps you to create an image, a .jar image of your given project application. And then lastly, we have GitHub actions or GitHub action workflow to perform the different stages in a Maven build cycle. So this is more information around Maven. Now we equally have, here's the architecture of what we are going to be building. This demo will be done on Amazon Web Service Cloud, and we are going to be specifying a region. You can use any region. For this architecture, we use US West 2 to in this architecture, we use US West 2 to provision our resources. And then basically we have developer A and developer B writing our Java code. They'll push this code to a repository in GitHub, which we are going to set up, a practice Maven repository, which we are going to set up to be able to manage our given file. And then equally, once we have the code stored in our GitHub repository, we are going to pull this code from our GitHub repository into our Maven server, which will give us now the possibility to run the various Maven commands. We'll be able to validate our project. We'll be able to compile, test, package, and possibly deploy our artifacts. So this is a basic environment setup for our given project. And of course, these are the tools we are using Git to be able to enable. We are using Git for, of course, our version control as a version control or our source code management system. We're using GitHub to store our source code. We're using Apache Maven for the build, and EC2 instance to run the configuration file. So this is how to configure environments. You create a GitHub repository, you name it Maven Learning Project. Since I already have this repository, I'll rename it Practice Maven when I'm creating mine. We equally have the configurations for setting up Maven server. We create an Amazon EC2 virtual machine. You install Maven, and then of type T2 micro, you have a security group port 22 open, which we are going to access this EC2 instance from or using the SSH protocol. You can select the key pair which you use, and of course we can follow the installation steps which is equally embedded in this repository. So to install Maven, these are the installation commands. They are equally part of this repository. So if you click here, it will take you to the installation commands. These are the installation commands. We are going to run these installation commands to install Apache Maven and Java 8 on our EC2 instance, which we will use to configure our Maven server. Now if you come back to the learning repository, other things worth noting is we have the Maven installation guide in this Maven installation folder. We have our setting.xml file. We use this setting.xml file to configure push for the various configurations which SonarQube will be using. Most importantly, on the line 86 to specify your SonarQube server, and of course line 74 to specify your Maven, to line 74 to specify your Nexus, as well as line 63 to specify your Nexus servers. So these basic files on your basic setting.xml file helps also configure environments for SonarQube and for Nexus. And then equally, we have our Java code. The code itself which we'll be running is found in this Java application code, and the code has our SCR or SRC, which is the project source code, which has the main. And then if you go detailedly, you'll see the code which was written in Java. This is the basic demo application test.java, the code which we are going to be building. And then we equally have in this same repository, we have the this is the test. We equally have the same for the main. Remember, I mentioned that the main is the main source code, while the test is the unit test cases. So the project has both the main for the main application code and the test for the unit test cases. And of course, we have our pom.xml file, one of the most important files, which I mentioned as far as a Java project repository is concerned. Our pom.xml file has all the necessary configurations for this given project. We have where we specify the necessary details of our project, the name of the project, our snapshot version, and then we go as far as specifying the various plugins, the build plugins, and then we specify the repositories for our Nexus, the Nexus build repository. We equally you must replace this. Once we get into the hands-on, you will see how we are going to effectively manage our repository to ensure that all these various commands or all these various configurations which we'll specify in our pom.xml file will give us the necessary plugins and dependencies to run the project. So let's go ahead to create our project repository in the next video.